Well, I've been looking forward to this for a long time. Dan Goldin is the longest serving NASA administrator, served 3 presidents, George I, Bill Clinton, and George II. But he has a long history before that. He started in NASA and then was a senior executive in TRW before he became NASA administrator. And then he has formed a company, Intellisis, which we're going to talk about as a new emerging pattern recognition company. But I want to go back to NASA. How many of you have seen The Martian, the movie? Okay, it's just come out, considered to be one of the most accurate depiction of what NASA might do by, say, 2030, which is their current timetable. So Dan, what about this not getting to Mars till 2030? What was your plan?
My plan in 1962, when I graduated the City College of New York, I am ancient, by the way, was to go work for NASA, not in Houston, not in Huntsville, where the real action was on Apollo, but to go to NASA Lewis in Cleveland, Ohio, where they were working on plasma propulsion and nuclear power with the goal of getting to Mars before the end of the 70s. And it was fascinating. We literally built these 5-foot diameter ion engines. And by the way, why do you want to do this? Every rocket you see today, with the exception of a few, is based on chemical combustion, and you're limited in terms of miles per gallon. It's the thrust over the mass flow. But if you accelerate using electromagnetic or electrostatic forces, you get more miles per gallon. Instead of taking a couple of years round trip, you could do Mars very, very fast.
Right.
So I left NASA in '67 when it became clear that Apollo was going to come to an end after we landed on the moon, and I decided I wanted to do something more interesting.
So I think this is one of the things that people forget about, that we actually had plans to do a lot of these things way earlier, and it's our choice as a country not to have done them and to continue now to put them off. So I come back to what you were doing in TRW before you went to NASA, before you became administrator. What convinced you that you wanted to be a NASA administrator? I mean, you were very successful in industry. You were
George H.W. Bush wouldn't take no for an answer. Well, it was an opportunity for time number 2 to go back to Mars. And George H.W. Bush had set out a plan to go to Mars, and this was in 1990.
Yeah.
And they were going to take 30 years and spend $350 billion with a B dollars to go do that. It wasn't George H.W. Bush, but NASA got into this mold, let's do it like Apollo. Let's constrain ourselves by saying you could correlate safety and spending money 1 for 1. And let's use the same old tools. Information technology had just exploded, and they forgot on the moon, you're just a few seconds away at the speed of light. Mars, you're a good fraction of an hour. Everything has to be autonomous. Everything has to have human-like qualities in the information system. So I went back, he lost the election, and I was blessed with building the International Space Station, which is a good thing because it was the end of the Cold War. And at that time, the Russians were about to sell missiles to Iran, Iraq, and North Korea. And they desperately wanted to be part of the World Space Program. So President Bush, then President Clinton, and then President George W. Bush brought them into the International Space Station, which really helped them come out of the Cold War. Unfortunately, now they're going back in, But I'm really proud of what we did, and in spite of all the tensions right now between America and Russia, they're still flying the space station. It's gone for 15 years, not a scratch to a person, 1 million pounds, bigger than a soccer field. 500 astronauts roughly have been there from 16 different countries, and we actually have peace in space.
So given that we have done this extraordinary engineering feat, for those of you, I don't know how many of you have actually gone through the actual life-size space stations that are available, like at Johnson and other NASA centers. It's just an unbelievable accomplishment. Do we really need these giant rockets that NASA is currently building? I mean, it seems like we've learned how to build stuff in space.
Let me not comment on what NASA is doing, because I haven't done that. I love the people at NASA. Right. Let me also say something else. People come up to me and say, what's wrong with NASA? There is nothing wrong with NASA. NASA, it reflects the spirit of the American people. And when the American people want to do something, they empower NASA to do it. When the American people are feeling uncomfortable about themselves, when they are afraid, concerned, that reflects itself to the people at NASA. They are wonderful people, and I do not want to criticize what they're doing.
Of course. From a technical point of view, is there an alternative? I mean, much as we ended up doing Apollo by working in lunar orbit, is there a way that we could build something in space up above the gravitational potential where it's not much different to go to the moon, to go to Mars?
Absolutely. If anything, the space station proved I could put 1 million pounds into orbit by building individual modules, and literally they got built in 16 different countries, and they came together in space. Information technology did it. It's not the plumbing and the electricity, it's the brilliance of the people in the IT. Mm-hmm. So we could take very modest-sized rockets, take Elon Musk's
SpaceX.
What's his rocket? The Falcon 9. Then he's coming up with the Falcon
Heavy.
27. These things are going to be plenty big. You don't need a very big rocket, and they're very inexpensive. You take them up, and then you build a smart robotic front end. If we could build automobiles that could self-drive on Earth, we certainly could build the robotics. These things could come together without astronauts. You assemble an orbit, and boom, you're off to Mars.
So I'm fascinated by your early understanding that we were going to need machine intelligence, basically, to get to Mars. Why wasn't the Silicon Valley industry on this back in the 90s?
There's something happening in information technology that I started seeing in the late 80s. As the Cold War was ending, I had to lay off 5,000 people. Just think about that number. I got physically sick. And I wanted to make sure that my remaining employees had exciting things to do. So I started exploring neuroscience, because most of our software system are based on information technology that's instruction-based. And when you have instruction-based systems and you have software you reuse, you build a house of cards. And all of a sudden, I build systems, Windows, Office, I don't know, 35 million lines of code. Facebook, 80 million lines of code. Linux, I think, has a couple of 100 million lines of code. And it's all built on systems that were developed before to save money. And it's brittle. One element could cause it to crash. It is susceptible to security breaches. We human beings are testimony that you are not brittle, but we learn by making mistakes. And I became fascinated with that concept. And I thought it through, and I was going for number 3 to get to Mars. I had failed because we had to do the space station. So in the year 2000, I calculated what we would need for an information system, and it was going to be 30 million lines of code. And I said, this is hopeless. NASA, which is a government agency which requires ultra reliability in its software. I love Windows. It's not reliable. Every time my computer hangs up, I have words for them. But
Sorry, Microsoft.
I love Microsoft too. But the point is, it was not the rockets. We know how to build rockets. We know how to protect people from cosmic radiation. We know how to supply food. We know how to grow food. We know how to land. We know how to take off. How do you do a system with 30 million lines of code, build intelligence into it so the astronauts have a fighting chance? This is not, you know, the early 1900s with pilots with silk scarves around their neck flying in planes that could crash without all the regulation we have. You need machine intelligence, and it needs to be biologically based. So I approached the Silicon Valley folks and made this pitch to them. This is the year 2000. We're going to have a national election. 9/11 hadn't happened yet. My concern was our young people needed something at the core to inspire them besides mindless video games, something above normal life. So I made the following pitch to the candidates, both of them. If you're elected, on May 17th of 2001, fill the Rice University Stadium, and at the exact minute, hour, second, make the following speech. Before the end of the 21st century, before the end of the first decade of the 21st century, we will land an astronaut, not a man, on Mars, and bring that astronaut back safely. I said it would electrify. I flunked. But I went out to Silicon Valley and I asked them, what do you think about, I'll put in some billions, you know, we had a $15 billion budget. Over a 10-year period, we put in some billions from the government. You guys put in some billions. And we transform information technology and not just worry about statistics and instruction-based systems, but integrate neurobiology with physics and computer science. We transform everything. I was laughed out. So I said, hell with it. I'll start my own company. And then unfortunately, George W. Bush sent a transition team to my house after he won the election. I was there one more year and I burnt out, and I spent 3 years with Gerald Edelman, a neuroscientist in San Diego. I went to San Diego because of you. I spoke to you years ago and you convinced me to go there. And I'm not formally instructed in neuroscience, but it inspired me, and I started my company in 2005.
So tell us a little bit about Intellisis. What are your goals, and how do you think about, you know, given that Silicon Valley couldn't get the picture, you're just going to do it anyway. And Dan, you know, I'm a young person compared to Dan, so I mean, this is...
Stop bragging.
I'm incredibly inspired by Dan's incredible persistence. But anyway, tell us about Intellisis.
I wanted to build a company that would, certainly not with the resources I had before, address critical issues in machine intelligence, and to give the person, not the corporations, each individual control over their lives. Let me take a very simple problem, voice. If you take a look at all the voice systems today, they're based on the same core theory, and then they use neural networks to try and clean it up. But the basic structure of how they go at it is different. So I love Siri. I have my Google phone. I have my iPhone. I've used Google Voice. They fail in noise. And let me step back a minute, and I want to define what I mean by noise. When people think about noise, they think about channel noise, they think about environmental noise. But in 2015, noise is malware, noise is viruses, and noise is unstructured data, which Joe was talking about. Mm-hmm. And you have to be able to efficiently, almost instantaneously, be able to get at signals and not filter them, but extract them from the noise, and then classify them, and give a performance that's light years better than a human being can have, because this noise requires too much processing. It's beyond the capacity of the human brain. In fact, one of the products that we have operates in environments where the noise is more than an order of magnitude than the signal of the voice. The humans cannot hear what's being said, but the machine could do it. So having that capacity enables people. All of a sudden, you don't have to rely on a password, which is fixed and could be stolen. You don't have to rely on a fingerprint, which is fixed and can be stolen. You don't have to rely on a retinal scan, which is very expensive.
Yeah.
And who wants to take an iPhone and put it to your eyeball? The voice has a voice print. And now people could have confidence that their stuff could be much more secure. You do two-factor, and you've changed everything.
Secure authentication, critical for the future of the internet. How did you were in Gerald Edelman's Neuroscience Institute in La Jolla for a number of years. You extracted some of the essence of what he had spent his life understanding about how the brain works. So then how did you turn that into a processor?
I have an expression. It's not mine, it's from Michelangelo. He said, "I see the angel in the marble, and I carve till I set it free." And in each phase of my life, what I try to do is not think about tomorrow and how much money I want to make or how many awards I want to get. I try and think of a vision that's 10 years, 15 years out.
Right.
I try and visualize and say, in 15 years or 10 years, this is where I'd like to be. And then I start working backwards to say, what's the first step I'm going to take?
What you have to do now to make that future possible.
And unfortunately, I couldn't do this in a corporation, and I can't do it in the US government now. So I decided at age 61, I'm going to start my own company. I took 4 years to sort of learn neuroscience. I don't claim to be a neuroscientist. And in 2005, I started the company. I didn't go to venture capitalists because I knew this was a 15-year process from 2005 to 2020 for raging financial success, but more importantly, to free up human beings to be in control of their lives. And I got patient money. I selected the investors in my company, and I said, be patient. It's 10 years to the first product, another couple of years to revenue, and a few more years to obscene profits. And having this vision and this roadmap, having worked backwards, I made a list of the kind of skills the company would have. And I also determined we needed to have people who weren't afraid to fail. And one of the problems I have with a lot of the graduate programs is because of the way they're funded with training incrementalists, that you read a bunch of articles and you find, how can we do 5 or 10% improvement? I'll write a paper, I'll get a patent. So I set a standard where I asked for people who were willing to fail. And I remember my first ad in Monster.com. I put out an ad on Monster.com that said, if you're an incrementalist, you need not apply. But if you want to change technology and you're not afraid to fail because failure is tolerable, apply, and you got to do an order of magnitude. And we landed a tenured professor of neurobiology from one of the top schools. And this is how we got our employees. It's still a very small company. And this little company with a few people has developed some very powerful speech algorithms. And then the next thing that happened is I bought some workstations. And we have a lot of parallel processing. I didn't want to have hardware because hardware is really hard. And we were seeing how slow it went. It was an order of 2 orders of magnitude. In fact, I came to see you. It was 2 orders of magnitude less than the advertised speed. And I called the manufacturer of this product and I said, why are you so slow? And he told me, you're not using it right. And then on the phone call, I said, oh my God, it's a SIMD machine, single input, multiple data, because it's a GPU. Yeah. It's you go pixel to pixel to pixel with the same equation. And if you want to unleash the potential of machine intelligence using neurobiological principles, you need a multiple program, multiple data machine.
Sure.
And I came to see you and I said, give me your smartest guy. And
you took him, unfortunately.
I took him. Nothing in life is fair, Larry.
Well, now turnaround is fair play. And thanks to working with Mark Anderson, I was able to announce here at FiRe for the first time on Wednesday that Cal IT2 is setting up a pattern recognition lab for just such processors. So
I'll say it. We're going into production right now of our first chip, and we have a series of 3 or 4 chips already planned. And as soon as we have the first test circuit board, I am personally going to take it and hand it to your people. But I'm not going to allow your people to use existing benchmarks, because existing benchmarks are written for existing hardware, and the existing hardware doesn't meet the standards from where we want to go. Let me just back off and say right now, when I first did my exercise on looking at IT in the year 2000, the worldwide IT web was taking a fraction of a percent of the world power grid. In 2011, I think it was like 10 or 11%. So we're driving for maximizing the ops or calculations per second per watt, so it has to be different. It took us 8 or 9 years, very painful, sweat equity. But what I'd like to do, and what I'm going to do, if you want the board, is we're going to specify that they're going to have to invent algorithms compatible with what the board is, rather than using existing stuff.
Great.
And they'll send the trend.
I mean, because that's the
and
whole
I'll
point.
drive them.
Yeah. Well, and you know, I mean, the way we work with companies is you'll evaluate whether this is adding value or not by working with the university. And if it isn't, you won't stay. And if it is, you'll come back. So, I mean, this is just what we need to drive innovation in this new space that's going to be explosive. Pattern recognition, as Mark Anderson has been saying for years. Now, let's see. Let's go to a question.
Hi. I was wondering if you would reflect a little more on the concept of taking risk as we see, you know, from a NASA perspective, both in the human risk involved, but also the federal government in funding basic research and early applied research is really scaling back their willingness to take risk on new ideas, and how that's going to impact the whole future of science and technology.
Let me define for you so you'll understand who I am and where I am before I define risk. I had to live through 62 shuttle launches. When I came to NASA, I was told the probability of a failure of the shuttle is exceptionally high, and when I went into the statistics, it was 1 in 72. Now think about that. 7 million pounds of thrust lifting 4 million pounds. Thousands of people involved, millions of lines of code. It is chilling to think. And our society has become so risk adverse. They're afraid of it, but they live vicariously through organizations like NASA. NASA, a set of supermen and women. I would go to the shuttle launches, I'd have to describe the torque on screw number 353 on engine number 3. Everything had to be done because NASA's perfect. But we human beings are frail. We make mistakes. And what has happened is there's such a fear of death, that we have to have perfection so we drive up the cost. And that gets into every area of life. And before every launch, and this is ultimately why I had to leave NASA, I stood in front of the media and the people at the launch pad, and I said the following words: I am personally responsible for the lives of the astronauts on that shuttle. If something goes wrong, blame me, not any one of the individuals sitting on those consoles, guaranteeing the lives of those astronauts. Because in America, as much as we have commissions, they generally search for the guilty and punish the innocent. That's the way it is. And it finally wore me down. So now I want to define.
This is a worn down person?
I'm really 35.
Yeah, I know. It makes me, I'm so jealous.
We are destroying the future of our nation by playing it safe. We live in fear of criticism. So basically, each individual that is applying for grants and each individual that is overseeing grants has to get it. And when the Congress starts screaming, you gotta fight them back. When the media starts screaming, you gotta hold your ground. It is shameful what's happening to unencumbered research. You need to unleash this force of the human mind, and you can't stand for it. You just can't stand for it. An R013, 4, from the NIH.
The personal investigator grant.
43 years old
The average
to
age
get
for
your
the-
first R013. Look at Elon Musk, what he did in his 20s. What the hell is going wrong with our country? But everyone is a lamb going to slaughter. So don't ask me, risk your career. I did multiple times.
Another question?
Hi, Dan. Nathaniel Miller, not representing NASA here. I might
NASA
be
Langley.
risking my career. I got a question. There's a lot of big companies in the room. And you've talked about, you're a hero where I come from and decried as a villain by the rest of the crowd for carrying NASA into the teeth of the dragon and really trying to push, really take the hardest social, technical, and political problem all the way out to Mars. So you've got some lessons learned. Can you share, there's a lot of large organizations here that are brittle with fear, as you just mentioned. Can you share some of those lessons and maybe some ideas about how organizations can soften that fear of failure?
It has to be pretty short.
It'll be very short. Organizations need people that in leadership have demonstrated they're not going to go through life wearing a white suit and allow dirt spots on that suit. They have to be dirty and they have to have failure. And the rule I said at NASA was, if you have 10 out of 10 successes, you're a loser and you're wasting money and you're wasting time because you're playing it too safe. If you have 0 out of 10, you're incompetent. But life is about, to get to success, you need 1 or 2 failures out of 10. This is how the brain learns how to connect the wires. So I would look at the leadership in these organizations, and I'd look at the people in the organizations, and I'd run that test, and I'd clear the deck of anyone that failed that test.
Thanks, Dan.
Thank you.